All right, so today we'll be looking at 6.4, which will be rational equations. Oops. So far all we've looked at are rational expressions which don't have an equal sign in them. We've just been simplifying without an equal sign. Now we'll actually be solving for the value of a variable because we will have equations which contain an equal sign, of course. So solve each equation. So this is just some background. Isolating a variable, add 7, so 2x equals 18. And then of course that are attached by multiplication, so divide by 2, x equals 9. A variable on both sides, subtract 5x over here and over here, subtract 9 here and here, okay, and we get on the left side negative 12, and on the right side we get 2x. Divide by 2 and we get x equals negative 6. Here we want to get the variable only in one place, so we have to distribute this 2 in, so we get 2x plus 8 equals negative 3x divided by 2. Now this 2 is attached by division, so we're going to multiply both sides by 2. So we go times 2 again, and we get 4x plus 16 equals negative 3x, because these 2's cancel here. Add 3x to both sides, subtract 16 from both sides. Okay, these are gone, these are gone. We get 7x equals negative 16, and x equals negative 16/7. Factor each of these. We have just beat factoring to death, but I guess it never hurts to get a little more practice. So multiply to give you negative 18 and add up to negative 3. The answers will be minus 6 and positive 3. There you go. Here we know we can take out a 2. Let's try that first. 2 would leave us with 25x squared minus 81. Alright, now this is actually a difference of squares. 25 is a perfect square, x squared is a perfect square, 81 is a perfect square. So we get 5x minus 9 times 5x plus 9. Here a 3 will definitely come out, and we'll be left with m squared minus 22m plus 363 divided by 3. 363 divided by 3, and that's 121. 121 is 11 times 11. So this is 3 times m, so m minus 11 times m minus 11. So negative 11 times negative 11, positive 121, but adds up to negative 22. There you go. Rational equations, so this is what we'll be focusing on. Identifying non-permissible values. So again, things that make the denominator 0, can't have it. Determining the solution to an equation, and then solving problems using rationals. So, to solve each rational equation, this is all in the textbook. I want you to find the appropriate page and fill in these blanks to give you an idea, and then once you have that, go on to the next page and we'll start getting some practice together. So solve the equation. What are the non-permissible values? Let's start with this. I might have put this page in the wrong spot when I was moving things around. In order to solve the equation, we want to basically get all the variables to one side of the equation. So we can multiply both sides by this entire denominator, x squared minus x minus 6. Okay, so what this means is that we have 3x times x squared minus x minus 6. Now let's factor this thing too. This will be factored as x minus 3 times x plus 2. So we're going to multiply 3x times x minus 3 times x plus 2, and this is all over x plus 2. But of course this has to get distributed to this and to this, so we go 5 times the same thing, x minus 3 times x plus 2 over x minus 3. And of course on the right side we multiplied by this, so that would just cancel and all we'd be left with is minus 25. And here your x minus 3's will cancel, here your x plus 2's will cancel, so we're left with 3x squared minus 9x, so by distributing this in, and then subtracting 5x plus 10 by distributing that in, and that equals negative 25. So get everything to one side. 3x squared minus 9x minus 5x will give us minus 14x. And then here we have 10, but we're going to add 25. Add 25. So we get plus 35 equals 0. And then this you're going to have to factor and just solve for the values of x. And here are your answers. And we forgot to talk about non-permissible values, but based on these two denominators and this denominator, because it factors out to that, your values of x can't be negative 2, because that'll make this 0, and it can't be 3, because that'll make that 0. Okay, there you go. And here's example 1, the one we meant to do first. Doc. Yeah, get out of my face. Weird. Alright. So this one we're going to try to solve here. And my recommendation is multiply everything by the denominator with sort of the most in it. So 2 over z squared minus 4. Now z squared minus 4 is a difference of squares. Z minus 2 times z plus 2. And to that we're adding 10 over 6 times z plus 2. And that equals 1 over z minus 2. Let's multiply everything by every denominator. So how do I want to go about this? You multiply this z minus 2 over to the other side, and we get 2 times z minus 2 over z minus 2 times z plus 2 plus 10 times z minus 2 over 6 times z plus 2 equals 1, because the z minus 2 disappears over here, right? Because we multiplied everything by z minus 2. So we move that up over to the other side. Now, these will cancel, but we're still left with the z plus 2 in the denominator. So I want to multiply everything by z plus 2. So 2 times z plus 2 over z plus 2 equals 10 times z minus 2, because this is still here, times z plus 2 over 6 times z plus 2 equals excuse me, and sorry, this was supposed to be a plus, not an equals, and we just multiplied everything by z plus 2, so on this side we get z plus 2. So 1 times z plus 2. So the z plus 2 will cancel here, the z plus 2 will cancel here, Now we're starting to get something that will look a lot simpler. 2 plus 10 times z minus 2 over 6 equals z plus 2. Now we only really have one more denominator to get rid of, and it's a 6. So multiply everything by 6. So we get 12 plus 10 times z minus 2 equals 6 times z plus 2. So when we multiplied this by 6, we got 12. When we multiplied this by 6, the 6 is canceled, and we're just left with that. When we multiplied this by 6, obviously we get that. So 12 plus 10z minus 20, so just distribute that in, equals 6z plus 12. Now let's get all the z's to one side. So subtract 6 from both sides and we get 4z. And then we're going to subtract 12. So the z's are taken care of. And then we're going to subtract 12 and we're going to add 20. So 4z equals 20 because the 12's are gone and you're left with plus 20, and z equals 5. And you're done. Did they ask us to find non-permissible values? Okay, non-permissible values. So look at this denominator. 2 is not allowed. Minus 2 is not allowed. Here, minus 2 is not allowed. That's the only one. And here, 2 is not allowed. So these are the only non-permissible values. X can't be 2 or minus 2. All right. Solve and verify. What are the non-permissible values? There are no non-permissible values because there is no variable in the denominator. So nothing's not allowed. But if we want to get rid of all these denominators, we need to multiply every term by essentially every denominator, or the greatest common denominator between all of them. And that is actually 30. So if we multiply everything by 30, all these denominators will disappear. So 30x over 3 minus 30 times 2x minus 2x minus 1 all over 5 equals 30 times 7, 7 all over 10 minus 30 times 1 minus x over 2. Now I said it would get rid of the denominators, and here's how. 30 divided by 3 is 10, so that leaves you with 10x. 30 divided by 5 is 6, so that leaves you with 6 times 2x minus 1. 30 divided by 10 is 3, that leaves you with 3 times 7. And 30 divided by 2 is 15, so that leaves you with 15 times 1 minus x. All the denominators are gone. So here we have 10x. Distribute the negative 6 in, so minus 12x and then plus 6 equals 21. And then minus 15 times 1 is minus 15, and minus 15 times negative x is plus 15x. So let's start isolating here. Let's subtract 10x. Subtract 10x. Okay. So that'll leave us with, oops, let's not jump ahead yet. And then let's add 12x and add 12x. So the difference here is 2. 15 plus 2 is 17x. Let's add 15. Gone. Subtract 21. So we add 15, subtract 21. So 6 plus 15 is 21. And subtract 21 and we get 17x equals 0. Okay, and x equals 0. That's weird. 6. Okay, well, let's see if we can verify. 0 over 3 is 0. Minus 2 times 0, which is 0, minus 1. So that leaves us with negative 1 over 5 equals 7 over 10 minus 1, and this is minus 0 over 2. So let's see if this is true. Negative of negative 1/5 is 1/5 is equal to 7 over 10 minus 1/2. So 1/2 is 5 over 10. 1/5 equals 7 over 10 minus 5 over 10. 1/5 equals 2 over 10. And of course, you can reduce that fraction. 1/5 equals 1/5. Hooray, it actually works. So x equals 0 is the only solution to this problem. Awesome. Example 1, your turn. So go ahead, go through this, see what you can make of it. The answers will be here when you're done. There you go. Hopefully you're able to come up with that. Example 2. I'm going to leave you to look over this because we already did the your turn number 2 accidentally. So I want you to look over this solution, see if you can make sense of it. It's kind of busy, but basically all we're doing here is we're taking the biggest denominator, or we're taking every denominator and we're multiplying every term by every denominator, so that a whole bunch of things are going to cancel, and then we'll be left with simpler expression. Alright, using rational to solve a problem. So here's the problem. These two people, they do a paper route in different amounts of time. So they share a paper route. Sheena can deliver the papers in 40 minutes. Jeff's lazy, so it takes him 50 minutes. So how long to the nearest minute does the paper route take if they work together? Interesting question. So the time to deliver papers, Sheena delivers all the papers in 40 minutes. Jeff delivers all the paper in 50 minutes. Now when they work together, we don't know how long it takes them to deliver all the papers, so we're just going to call that T. And that's what we're going to try to figure out, right? That's what the question is asking. How long does it take them to deliver all the papers? Okay, now the fraction of work done in 1 minute. So if it takes her 40 minutes to do all the work, then in 1 minute she does a 40th of the work. So she does that 40 times and she's done. Jeff does it 50 times and he's done. Now, together, in 1 minute, they do 1 out of T. The total amount of time it takes them, okay, they do 1 out of every T in time T. Or in 1 minute, sorry. Fraction of work done in T minutes. Okay, so T minutes, this is kind of tricky to understand. But if she does 1/40th of the work in 1 minute, then in T minutes, she does T 40ths of the work. Okay, so T can be any amount of minutes. In 5 minutes, she'll do 5/40ths. In 12 minutes, she'll do 12/40ths, okay? So Jeff does T 50ths of the work in T minutes. And together, they do all the work in T minutes, right? Because it takes them T minutes to work together. So the fraction of the work done in T minutes is 1. And they're working together. So here's how we figure this out. Sheena does T out of 40. Jeff does a little less, T out of 50. But when they do T out of 40 work and T out of 50 work, that's all of the work done in the amount of time t. So here's our rational expression. Now to get rid of the denominators, multiply everything by 50 and then multiply everything by 40. So 50 times 40 times t over 40 plus 50 times 40 times t over 50 equals 50 times 40. Okay, so we've multiplied this by 50 and 40, this by 50 and 40, and this by 50 and 40. 40's cancel here, 50's cancel here, nothing cancels over here. So we get 50t plus 4t equals 50 times 40. 5 times 4 is 20, and then add 2 zeros. There you go. So 90t, which is the sum of 50 and 40t, equals 2,000. Now divide each side by 90. T equals 2,000 over 90. So 2,000 divided by 90. Okay, T equals 22.2 minutes. It will take them together to deliver all the papers. Hey, my doc disappeared. That's great. So let's just see if we confirm that. 200 over 9. Okay, I did 2,000 over 90, which is the exact same thing. Let's go. Let's not go that far. Whoa, okay.
Please excuse the interruption. Can I have your attention, please? Can the senior boys volleyball team and Mr. Dahl please report to the home ec room? Senior boys volleyball team and Mr. Dahl to the home ec room, please.
Okay, to be continued. Okay, so let's pick up where we left off and get this quickly finished here. Jason, you can hit pause and read the question. The number of minutes to eat a bag of popcorn, it takes Jason 20. Takes Rochelle 25. Together we don't know. Well, we'll call it X because they use X over here. So it takes them X minutes together to eat the popcorn. Jason, in 1 minute, he eats 1/20th of the bag. If it takes him 20 minutes to eat the whole bag, then in 1 minute he eats a 20th of the bag. Rochelle eats 1/25th of the bag. And together they eat, 1 out of X of the bag. Fraction of popcorn eaten in X minutes. Jason eats X out of 20. Rochelle eats X out of 25. Together, they eat X out of X. It takes them X minutes to eat the entire bag of popcorn. So that'll be 1. So, together, Jason plus Rochelle will eat 1 bag of popcorn. Alright, find yourself a common denominator. 100 is your smallest one, so multiply this by 5. 5x over 100 plus this by 4. 4x over 100. And that equals 1. And we have 9x over 100 equals 1. 9x equals 100. X equals 100 over 9. Or if you want to put an actual value, decimal number on it, 11.11 minutes. I want you to take a look through this question and just see if you can make sense of the numbers that I've put in here and everything that I've done. Pause it just so you can discuss it and think about it. So between this step and this step, I've multiplied all three terms by both denominators. So the v plus 3 cancels in this one, but leaves this. And the v minus 3 cancels in this one, but leaves that. Nothing cancels in this one, so everything's left. And then distribute everything in. Okay, so 15 times those. And then FOIL this, oops, and distribute the 3 in. And then solve, and I solved by completing the square here. Okay. Here's your turn. Go ahead and give it a try. See if you can make some sense of it. Here's your answer. You probably put it in decimal form, so just 12 divided by 7, and you get 1.714. Okay. That's all we're going to do for now, so I'll see you in class.